All right, let's get started. Okay, somebody tell me what you just finished learning. What have you just finished up with?
Ecology.
You just finished with ecology. What part of ecology? What did you learn? You've learned all that stuff already, the biomes and all of that good stuff? Okay. Well, today we're going to be going over the succession part of ecology. And I need to go over here to make this advance. Succession. Who remembers what ecological succession is? Anyone? All right. That's good. So, I'm going to start you off with this slide. And then we're going to do a little activity. It's what we call an anticipatory activity. You may not know the answers. You may know the answers. You've had this a number of times in different years. So you probably know the answers. You have your books. You can definitely look up the answers if you find them in your books. But it's not a graded activity. It is something that's going to kind of prime the pump. Let us see what we know so we can move on from there. And we'll go over them together. And then we'll go through the slides and the information. And then if there are any questions, we can go from there. Does that sound good? Okay. First slide is about community ecology. Who remembers what a community is? It's a population. Populations together. What's the definition of a population? Species together, interact. Good. All right. So we've got the organism, the species, the population, and the community. The community are those populations that occupy the same area at the same time. Okay, that's important. It's a time-limited thing as well, and area-limited as well. If you have different species and different populations in different areas, they are not a community, right? And then ecological succession is a change in an ecosystem when one community replaces another due to changing biotic or abiotic factors. Right? A lot of little terms in there, but that's okay. That's what we're going to go over right now. So if you guys could kind of pass these down, then we'll review them. You can take notes on them if you want to. If you prefer to take the other kind of notes that you've been doing in your class, you're welcome to do that as well. Mrs. Collins has asked me to let you know that this stuff is on the quiz, so even though this is not graded per se, the information will be pertinent for you later. Go ahead and get started. I'm going to give you till 1/4 after, so about 7 minutes. All right, let's go with that. So let's start with this fun times, right? Monday morning, first period, quiet, snoozing, going through a paper. Not exactly exciting time. That's all right, because it's going to get rolling. You can see in this sheet that if you got a couple of them right, it started to make sense. If you were stuck on one and you looked over to a couple of the other ones, they could kind of give you clues. So tell me about number 1. What's a change in the plant communities over time? What's it called? You can just call out. I don't need you to raise your hands right now. Succession? Right, what kind of succession? Ecological succession. Very good. Common pioneer organism? Lichens. What's a lichen? It's an answer to another question. A lichen. A lichen. Has anybody ever seen lichen before? Have you seen lichen right here? Yeah? Okay. Where have you seen it?
On trees, mainly, and rocks.
On trees and rocks. Yeah, that's right. Mostly rocks. A lot of times what we see on trees is more fungi. but lichen is definitely on rocks. It's kind of a peely, scaly. Yeah.
Is it like that white stuff that's on rotting wood and like fences and stuff?
Okay, sometimes, usually that's more of a mildew or a mold. Lichen is sort of an algae fungi combination,
But it's like flaky and stuff?
but it's flaky. Have you ever seen like a big rock that has like, it looks like green paint peeling off of it, but it's not paint, and you know it's probably alive, but it doesn't seem like it's alive? It's alive, and that's lichen. And lichen is, in the fourth question, is the first organism in a succession. It's called a, what kind of? It's a pioneer. Why do you think it's called a pioneer? It's the first one there. It's the only thing that can survive, right? You can't usually grow a tree on top of a rock. It just doesn't work. So the lichen starts out there. Let's jump back to number 3. The final stable state in succession is called a what? A climax community, right? That's the peak. That's the end. That's as high as it can get. Okay. 5. Ground is cleared, grasses began to grow. What's it called again? Ecological succession, right? Repetitive. Number 6, we're going to talk about lichens again. Number 7 is a little tricky. What's the answer to number 7? Which stage represents a pioneer community out of those 4 stages, A, B, C, D, or E? Which one? B. Why B? B is annual grasses. It's not lichen. Why would you say B?
Because it's the first thing after the wipeout. And like, when there's nothing there, it's the first thing that comes up. Instead of lichen.
Right. How many species are there in freshly plowed earth? None. So if there are no species, we can't call that a pioneer because a pioneer is a kind of a species. Does that make sense? Okay. All right. More ecological succession. Climax community. Number 9. What's a good example of a climax community? Which one? E? D? Which one?
E.
E. Why E?
It's the last one.
It's the last one on the list. I'll go with that. Why not birch and cherry? What's the difference?
The final stable state.
Are birch and cherry not hardwoods and deciduous like beech and maple?
They are, but it's a beech maple forest.
Awesome. Very good. Good eye. Very good. Excellent. All right, more ecological succession. Flip it over. Let's look at the pictures. We all love pictures. 4 stages of biological process. Probably would be better to call it ecological succession. Is it a pioneer species?
No.
It's just a rock.
No? So it's saying, what would be the most likely predominant life form found in stage 1? Rock. And obviously, block is not the right answer. So, ferns, pioneer species, trees, or mushrooms?
Pioneer species.
Yeah, even though it doesn't show any pioneer species, that would be the only thing that could live on the rock. So, number 4 is that climax community that we've been talking about. What can change a climax community? If we're talking about a stable community, it doesn't usually change. What will make that climax community change?
1.
A major change in an abiotic factor? Okay, I'll buy that. What's an abiotic factor?
Like people coming in and cutting off trees and whatnot.
No. Weather.
Weather? No. You said what?
Volcano.
Volcano? Okay. Cutting down trees, I wouldn't go with cutting down trees. The reason I wouldn't go with cutting down trees is because there were people who did it. People are biotic.
Alright.
So, probably couldn't go with that, even though it's not a natural thing. You can think of it the same way as locusts coming in and eating a field of wheat. That's a biotic factor. They're destroying it the same way we destroy forests, so we couldn't use that. But a volcano, even though a volcano is a natural thing, it's not biotic, right? It's just fire and rock and it's burning everything up. That's a good one. Weather is a good one. What's another abiotic factor that can affect a stable climax community? Abiotic. There's more than two. There's more than volcanoes and weather. Some kind of natural disaster. What would be a good example of a natural disaster?
Should we have an earthquake last night?
I did
It
not.
was 11.21. Yeah.
Did you feel it?
No, I didn't. I did.
Yeah.
I felt it.
I didn't feel it either.
Did you really?
Actually, what time was it?
11:21.
The door on my porch was banging at 11:21. I thought it was the wind. Yeah. Wow. Interesting. Yeah, and an earthquake, a big enough earthquake. They just had a huge earthquake. Where was it? Was it in Mexico? Chile? Chile. How big was it? Huge.
They didn't call for it.
Yeah, but that kind of thing destroys towns. It destroys forests. It causes landslides. A landslide would definitely wipe out a forest. So that's a good one. All right, let's jump down to the pond pictures. Ecological succession, yada yada. By 2050, the area will most likely be what? Forest. Not a desert. Forest. Because life tends to keep going. Only something abiotic or biotic that was a disaster would get rid of it and create a desert. So what causes that increase in the vegetation? How do you get a forest out of a pond?
Decreasing water depth.
Okay. Okay. Water depth doesn't usually decrease unless there's a change in the weather, and that's not usually a positive thing. That would be an over-evaporation. It might be okay to cause that succession, but probably not. There's something else that's more likely.
Increase in the numbers of organisms.
Yeah. Yeah. Has anybody ever been in a bog before? Does anybody know what a bog is? Okay. I used to live in northern Wisconsin. We had bogs everywhere. Northern Wisconsin is full of lakes. The plants grow. You have reeds, you have shrubs, you have bushes that grow around the edge. And they just kind of, in the summertime it gets a little warmer, and the water might decrease, like you said, because of evaporation. And so they grow in a little bit. But then the water comes back during the winter time, and it ends up killing some of that shrubbery and whatnot, and it dies and it sinks down. And eventually, over a bunch of years, you get kind of this sloppy, nasty, spongy, gross area where you can walk through it. It might be knee-deep. It's usually very scraggly. In the center, there's usually a small pond, maybe the size of this room, rather than the size of a lake. Because it's all creeping in, and eventually, that center part will get filled in too, and then it starts becoming soil. The water is taken up by the plants that are there, and it starts to grow. And I can tell you that when I lived there, I was a wilderness instructor. And so one of the things that we had to do was take people out into the boggy area to teach them what that kind of wilderness was about. And you could be walking along in ankle-deep water and stepping on spongy, springy grass, and the next minute you could be over your head. You just never know, because that decay happens at different rates in different parts. So it could take a very long time or a very short time. It just depends. Okay, great. You guys knew a lot. That's awesome. I'm glad you held on to that. May we move to the next slide, please? Okay. Abiotic and biotic limiting factors. Those are the things that we're talking about that change the ecology. Limiting factors. Somebody name me another biotic factor that might be a limiting factor? People, okay. Let's take people and animals out of the equation and just talk about plants and the communities of the species and populations of plants that are in this community. What could be a limiting factor just with the plants? Sunlight, like in a rainforest perhaps, where you have the canopy and it prevents stuff from growing. Not enough rain. Okay, that'd be an abiotic factor, but that would definitely be a limiting factor, and that's the term that we're trying to learn on the slide. How about overpopulation? You think that ever happens? Absolutely. Absolutely, it sure does. Think of kudzu. Kudzu is a vine, crazy, fast-growing vine. It's a thing, when you're driving down the highway and you see the trees that are overtaken by the vines and it's just crushing them down, kudzu is overtaking the trees and all of the other vegetation. That's a limiting biotic factor. Next slide.
Kudzu is worse than bad.
Okay. And because there are limiting factors, did you have a question?
Oh, no.
Okay, that's all right. Because there are limiting factors, biotic and abiotic, there is going to be what's called a range of tolerance. This is the definition of tolerance. The ability of an organism to survive when subjected to biotic or abiotic factors, specifically biotic or abiotic limiting factors. And the picture that we have here is of steelhead trout. The higher the loop, the more steelhead trout there are. Okay, this is population, quantity of fish. This way is temperature in the water, starting at 9 degrees Celsius up to 25 degrees Celsius. So what do you gather from looking at that chart, just right off the bat? What does that mean to you? Temperature is a limiting factor, right? And in fact, if you can see these areas are a little bit small and a little bit difficult to see. It says the steelhead trout are infrequent here and here. It's a zone of physiological stress. They can handle it. They're nearing the edge of the limiting factor. When they reach 9 Celsius or 25 Celsius, they're not able to survive. It doesn't mean that they're killed. Rockfish, for example. We fish for rockfish in the fall and in the winter, mostly. We do in the summertime as well, but the big season happens around the beginning of January. The reason is because the temperature is right for the rockfish to be where we are in Virginia, rather than just down in North Carolina. They don't necessarily die, they might migrate in and out of the bay, especially where we live with the Chesapeake Bay. That's a really big thing. Okay, does that make sense? Got that. Range of tolerance, that's an important term. Okay, next slide, please. Primary succession. We've already talked about ecological succession. There are two kinds that we're going to talk about, primary and secondary. Primary succession is what we've been talking about. It's going from bare rock to lichens. The lichens die, get ground up. There's erosion as well. Creates soil. You get your small annual plants. Has anybody ever seen a flower or a dandelion growing in a sidewalk? Pretty hardy little things. They're pioneer plants in and of themselves. So we'll start out with those, and then they'll be overtaken with the perennial herbs and grasses, stuff that sticks around a lot longer. And then they'll grow up and get bigger grasses and shrubs and shade-intolerant trees. They're the ones that would die if they were under the canopy. And then usually the next thing that will grow are conifers and then deciduous trees. What's a deciduous tree? Any tree that what?
Well,
Dies.
not really.
Loses its leaves, right? Loses its leaves. That's what a deciduous tree is, and they are shade tolerant. We already talked about what a climax community is. We've already talked about a pioneer species. And we talked about a community unexposed rock without topsoil being established. Next slide. Secondary succession. We talked about this a little bit when we started to talk about biotic factors that can destroy a climax community. In California, they have wildfires raging all the time, right? A long time ago, not terribly long time ago, but a long time ago, for you guys especially, Mount St. Helens, the volcano out in the west, exploded. And if you've ever seen pictures of Mount St. Helens, sometimes they have them in your biology book, it looks like matchsticks. The top of it blew off, and all the trees that were there laid down, all in the same direction. It was amazing, like a bomb went off. If you look at that area now, you'll see terrific growth already, and it's only been maybe 30 years, something like that, maybe 40 at the most, and already forests growing there. Why? What makes secondary succession different from primary succession? Exactly. Could you say that louder? Right. All this stuff gets wiped out, gone. But you don't have to start from bare rock. Even with a volcano, when there's lava, think about the islands in the Caribbean or Hawaii. The lava bubbles up from the bottom and creates islands, and before you know it, you've got palm trees growing and grasses for some reason, and it's because there is the capability from that lava to create soil quickly, if that makes sense. It breaks up quickly. Life wants to be where life can be. So it is definitely faster than primary succession. Next slide, please. Okay, so then you have the endpoint, succession's endpoint. What is succession's endpoint?
Ecological succession stops.
Okay. Now we've just said life tries to be where life can be. So what can possibly make ecological succession stop?
People or bad factors.
Okay? We blame people for everything. People do a lot of good though too. So how about an ice age? How about extinction? You know, when these guys went away, they couldn't come back. There wasn't a way for them to come back, at least not that we know of. Sometimes we hear little snippets of things where we think that maybe something has survived in different parts of the world, but for the most part, all of these critters are gone. And this tree right here, this palm tree, that's extinct as well. It has a long Latin name. Please don't ask me to try to pronounce it. But even plants can be gone. They can go away. And these weren't our fault, right? It wasn't mankind that time. The determining factors can be anything. It can be locusts. It can be a meteor hitting the Earth. There are all kinds of different things that it could be. So understand that succession's endpoint, that's so easy to say, succession's endpoint is when it's done and it can't come back. And that's a sad thing. I was reading about black rhinos this morning. Black rhinos are gone, they think, because they were hunted into extinction in Africa to supply rhino horn ground up for the Chinese market. Because on the Chinese market, ground black rhino horn is more valuable per gram than solid gold. So they destroyed them all to get a little bit of aphrodisiac, which is a shame. Yeah, that's it for me. So today, thanks.